Okay, so basically, what in the organic chemistry, particularly, or for the analysis of an organic compound, the most important spectral technique, or the most important the characterization technique that is called as the NMR spectroscopy. And so, the NMR spectroscopy, in case of what the organic chemistry, is said to be the principal technique now. It consists of various different types again, 1H NMR spectroscopy, then 13C spectroscopy, we have 19F spectroscopy, we have 31P, then 11 boron, etc. etc. There are different types of what NMRs are there. And you know that organic compounds, most of the cases in which have the carbon and hydrogen. So that's why. And for organic compounds, most of the organic molecules have hydrogen and carbon. But hydrogen NMR is another one important technique now. Why? Because of the abundance of hydrogen is 99%. 1H hydrogen abundant is what? 99%. While the 13C abundant is only 1.1%. So that's why it is very difficult to record the sample of 13C. But the 1H NMR, you can easily record that spectrum now. Required very much little amount of sample to predict. Okay. And basically using that NMR spectroscopy, we can get the information about the type of a nucleus, type of a hydrogen. Okay. How many different set of hydrogen, how many equivalent, non-equivalent, etc. All the things can be done with the help of that the NMR spectroscopy now. So basically, in the spectroscopy, we are simply divided into two different classes now. Basically, spectroscopy is a physical method of analysis now, but the organic spectroscopies are nothing but the we have UV, mass, NMR, and IR. These are the four important techniques now, which is used to elucidate the structure of any organic molecule. And for the inorganic purpose, we have mass bar spectroscopy, ESR, XRD, etc. are there. That probably used in the inorganic for elucidating the structures of our inorganic molecules. Now, in the field of the spectroscopy, that NMR is again very much have their unique features, and they have a lot of applications again. And no one single technique give you the all 100% information. So that's why we have microwave, we have NMR, we have mass, we have IR, UV. Okay, then mass bar, ESR, photoelectronic spectroscopy, Raman is there. So there are different techniques are there because no one single technique gives the 100% information. So basically, you know that the spectroscopy is nothing but the interaction between your sample, between your order sample and the radiations which are coming from the source now. That is called as a EMR. Okay, and that sample undergo the physical change when it is interact. They undergo the physical change now, and that physical change which detected by detector now. This is called the physical change happen. Okay, and that physical change in terms of absorption, emission, in terms of one can say the scattering, reflection, etc., etc. Okay, and that physical change detected by what? The detector. And so finally that detector converts that whole information in the form of what? The spectrum now. Okay, so there is amplification and there are many processes is there now after the detector, and you will get the spectrum that is called as a two-dimensional graph now, and that graph have the information about your sample. So basically, any compound is made is comes from either from organic background or either from inorganic background. So basically, your compound or sample is divided into two different category. One is they can be synthesized in the lab. Okay, it may be organic, it may be inorganic, and either it can be obtained from the nature. Let's example from the plants, from the what the natural products. Okay, or from the microorganisms. So there are two types of what the compounds or the sample we have. They are originated nature as well as they are synthesized in the laboratory. Okay, and that compound or that sample can be evaluated with the help of what the spectroscopy now. So the spectroscopy is basically nothing but the what? There is an interaction between what the electromagnetic radiation and your sample. The sample in the form of what? The solid, liquid, or vapors now. Okay, there are very specific cities are there. For a particular technique, let's say IR, it required a solid sample. Okay, you can also done on the liquid. Okay, for mass spectrometry, you must have the gaseous sample. For NMR, you have again liquid as well as your solid one. Okay, so for every technique the requirement is different. Okay, so basically that spectroscopy is nothing but the interaction between the EMR and the sample. And what is the particularly aim of the spectroscopy? The aim of the spectroscopy is to determine the structure of unknown compound. It may be organic, it may be inorganic, right? So we can determine the structure by using that the technique now. So again, that compound is either from they come from the nature, that's from the plants or animal, and that can be synthesized in the lab now. Okay, and here this EMR, which is energetic radiations, that EMR have the wavelength as well as the energy as well as amplitude as well as the wave number as well as the frequency now. So all the parameter already included in that the EMR, and that EMR is interacted with the sample. That sample undergo the physical change. That physical change is detected by detector, and finally it will be undergo the amplification, and it converts into the spectrum. That spectrum have the information about the sample. Okay, and that spectrum is basically evaluated first. It should be evaluated, neither it the all are useless. You must evaluate that spectrum, because the spectrum have some numbers. Spectrum have some type of what the lines. Okay, there are called as a type of the spectrum, so it should be evaluated first. So basically what that unknown sample, the source of what unknown sample is either what the nature, either from the synthesized in the laboratory. Okay, and that first compound is isolated, it should be purified first, and then we are doing the analysis now. The analysis is again two types. One is the chemical method of analysis, and another is called as a physical method of analysis now. So for chemical method of analysis, we are doing the different chemical tests now. For the chemical test, we required the chemicals. Okay, we required the time again, and a lot of things are there. So and you need to require a large amount of sample now. That is the important condition here. But in the case of what the physical method, we need a very little amount of sample, and within a few time, or within a short time, you will get the more information about your sample. Okay, and in that case, the spectroscopy is the best example for the elucidation. The next one, here this is the difference between the chemical as well as the physical method of analysis. Now here in case of what chemical and the physical method of analysis, in chemical method of analysis, we are doing the chemical reactions. In physical method, we are not doing any kind of what chemical reactions now. So here sample cannot be recovered because we are doing chemical reactions, so sample is completely destroyed now. And here sample can be recovered now. Some exceptions are there, like mass spectrometry, we cannot recover the sample, but the remaining techniques are there, like UV, NMR, then IR. Okay, in that cases we recover that sample now. Now in case of a chemical method of analysis, it is a time taken process, but here it is a faster one. Okay, you will get the some we can propose a simple structure now. We cannot find the absolute configuration, but here we can find the absolute structure of a compound. Okay, that is a very important one. So this method is expensive now, because we are deal with the spectrophotometer or spectrometer instrument is there now, and they depending upon the nature of what radiations, that is nature of what EMR. Radiations means the nature of EMR, which electromagnetic radiations we are going to use now. So we are classified, or we are categorized into the different types of the spectroscopy. So here if we use the microwave, and you know that EMR is nothing but the CGX, UIM and R. What is that CGX, UIMR? That C means C for the cosmic rays, then gamma rays, then X-rays, then UV, that is ultraviolet visible, then infrared, microwave, and radio frequency. And you know that there is a principle, that is E is equal to H nu, that equal to HC nu bar, and that equal to HC by lambda. So here cosmic rays are highly energetic radiations, while radio frequencies are highly that have the highest wavelength. Okay, you can compare that factors, and based on that electromagnetic radiations, we have classified into different techniques now. First is called as a microwave, then second is the IR, then Raman, then NMR, then UV visible, then ESR, then optical, that is called ORD. Okay, we have photoelectric electronic spectroscopy, we have X-ray. Okay, and the mass. So every spectroscopic technique have their unique features now. Now, what are the unique features now? Let's say example, if you are dealing with the microwave spectroscopy, now, when microwave radiations are interacted with the sample, we can find the bond length, bond angle, and masses of the atom. Now. That is the utility of that particular technique. Microspectroscopy means when we irradiated with the microwave source, the sample start rotation now. That's why it will be called as a, it is called as a rotational spectroscopy. In case of what IR spectroscopy, when infrared radiations are interacted with the sample, your sample start vibration. That's why it's called as a vibrational spectroscopy now. And here, this technique is useful to predict the nature of function groups now. That is, function groups can be predicted with the help of this technique. Then next one is the Raman spectroscopy now. So Raman spectroscopy is basically deal with the, we can find the nature of the functions or nature of the groups we can predict it. So IR and Raman have some what the similarities there now. Okay, and these techniques are called as a comparable techniques are there now. Okay, they have some similar functions. Now NMR spectroscopy is basically when we irradiate with the NMR source, that is radio frequency. So we can predict the nature of nucleus now. So number of magnetically active nucleus can be found, and that means those nucleus having eyes greater than 0. UV visible spectroscopy, when we interacted with the UV source, that is ultraviolet visible radiation, then we can detect the type of chromophore, color bearing substances, color bearing groups like double bond, triple bond, okay, benzene, NO2, etc., etc., COH, etc. Then next to that of what ESR now, it is also called as a electron spin resonance spectroscopy, or it is called as a electron paramagnetic resonance spectroscopy now. So basically, this technique is again comes under the category of what microwave radiation, and this technique is especially used for radicals now. Paramagnetic substances are well detected with the help of what EPR, and that technique is the principally used in inorganic, because inorganic compounds are odd electron molecules now. Okay, and that's why the ESR spectroscopy is widely used in the you can also use the in most of the cases in inorganic system. The ORD, another optical rotatory the distortion. Now this technique is basically for the configurations. Now we can find out the configuration, and which is comes under the case of the UV visible range. The next one is called as the photoelectron spectroscopy. That is short form is called as a PES now. And photoelectron spectroscopy is basically where deal with the valence as well as the core electrons now. That is binding energy we can predict it here. Then X-ray, you know that X-rays are highly energetic one, so we can find out the absolute structure and also get the information about the core electrons. And then next to last one is called a mass spectrometry now. This is the only one spectral technique in which we are not dealing with the electromagnetic radiation. Remaining all techniques are here, which are listed here, in which the source is EMR, but the mass spectrometry, that's why it is called as a metry. Okay, so mass spectrometry is the only technique in a spectroscopy, especially here. These are listed here. Out of this technique, only mass spectrometry is the technique in which your source is non-EMR, that is highly energetic radiation, that is 70 electron volt beam is going to be used here for the ionization or etc., what are the processes there. So that's why it is called as a mass spectrometry now. Now with the help of this technique we can find the molecular weight, molecular formula, skeletal structure. Okay, and that is the one of the best advantage of this technique. Now, this is another one technique we cannot recover the sample now. This is the destructive spectroscopy now. Destructive means where a sample cannot be recovered. After recording that spectrum, we cannot recover the sample. But in case of what NMR, IR, UV, you can recover the sample now. So destructive and non-destructive. Okay, most of the cases we can call it as a non-destructive, where sample can be recovered easily. Here sample cannot be recovered, like chemical testing, like chemical and a chemical method of analysis, we cannot recover the sample. So these are all the spectral technique which are based on the EMR, which are based on the principle, which are based on the which source is going to be used now. So some important points are there. Let's say example, X-ray required highly crystalline compound. Okay, that is another important condition. But most of the substances are what nowadays amorphous or now the liquid. So here X-ray is not possible. But nowadays we can call it as a powdered XRD. We can call it as a single crystal XRD. Okay, and no one single spectroscopic technique can't give 100% information. That is another important. So that's why all the techniques are supporting with each other now. Okay, so whenever you want to deal with the accurate information, then we must proceed for more than 3 4 5 spectroscopic technique. Okay, so for organic sample, for if you are dealing with the organic compound, then in that case now, so we have 4 principal technique: IR, then NMR, then what mass, and finally UV. So these are called as a 4 important technique which are called as a they're specially for the interpretation of your organic molecule. So we have organic compound, then you must deal with the UV, NMR, IR, and the mass number. So now in NMR again we can have the 1H NMR and 13C NMR. So why the 1H and why the 13C? Okay, we will